Hi there, in this video I'm going to be going over the Unit 3 test review. So for the first question it asks, which of the following is not a function? Something is not going to be a function if the x values or the input, if any of the input values repeat. So let's look at each one individually because you never know, there may be two correct answers. So when we are looking at A, our x value for these ordered pairs is the first one in each set of parentheses, and these are all different, so this is a function, so that one is not going to be an answer. When we look at C, C has two values that repeat because 4 repeats and 4 repeats down here. 4 is listed twice. Therefore, this one, C, is not a function. With this graph for B, when we use the vertical line test, we notice that it only hits one point of this function at a time. So this one would be a function, therefore it is not an answer. And then lastly, D, when we use the vertical line test, it would hit all of the points at x equals 3. So therefore this one is not a function. So for number 1, the correct answers are C and D. All right, for number 2, this is a mapping example. And something is not a function, again, if the x value repeats. So if we were to write this as ordered pairs, maybe this would help you a bit. -2 is used twice. It's used with the y value -3, and then it's also used with the +5. So if we were to write this mapping as ordered pairs, I don't know if this helps you out, but it might. You see that -2 is used twice, and since it's an x value, this cannot be a function, and that is because x values repeat. So the correct answer would be D. Okay, so now we are on the second page, number 3. This says state whether the following relation is a function. This is a discrete graph, and that's because we just have dots. We don't have a continuous graph, which is connected, or a continuous function, which is connected. This can still be considered a function as long as none of the x values repeat. So if we use our vertical line test and go from left to right, we notice that we are at x equals 2 at 2 different points. So since the x value of 2 would repeat and my pencil would be on both of those points at the same time, this is not a function. All right, so for this next one, we have ordered pairs and we need to state the domain and the range. So the domain are our x values. So the first number within each set of parentheses. And when we're listing our domain, we need to make sure that we have those braces at the front and in the back, and then also that we list our values in ascending order, so from least to greatest. So I have a brace, and then I'm going to list 1, 3. I only need to list 3 once. I do not need to relist something if it's repeating, and then 4. And then I'm going to put the brace. Okay, and we're going to do the same thing with range, except these are our y values, so I'm going to circle those in red. Okay, and so we are also going to list these in ascending order. So we have -4, +1, 7, and 10. And the reason why we have more range values is because 3 repeated in our domain. All right, number 5 is asking, what is the range of the relation? So if I'm looking for a domain, I'm going to go from left to right. If I'm looking for range, I'm going to go from bottom to top. So I'm going to quickly draw that to the side of my graph. Okay, so I'm going to go from bottom to top. So the first thing I should do is draw the brace. And then my first value is right here, and it looks like that's at -4. My next value is right here, and it looks like it's at -2. My next point is right here, and it looks like its y value is -1. And then my last value is right up here, and it looks like its y value is +1. So that is the range of the relation. Okay, so now we are on the third page. We are at question 6. This is asking for the domain of the relation. This relation is continuous because it is connected. And when we are looking for the domain, we are going to go from left to right. Okay? So what I'm going to do is I'm going to take my pencil or something and look to, going from left to right, look to see where this relation where its first point exists. And as I can tell, the kind of like the bottom of the U of this relation, it hits at 0, okay? And when I'm talking about domain, I'm talking about my x values. So whenever we write this, we're going to want to make sure that when we're using our such that format, that we are including our x. So I'm going to write my braces, I'm going to write x, I'm going to write x such that, and I'm going to wait to write everything else because I want to look at this whole relation before I write it down. So I know that x is going to have to be greater than or equal to 0 because that is the first point that exists in that relation. And if you look over here in yellow, we don't see any points over here for this relation, okay? So the first point that we see is right here at this blue dot at 0. Then if we keep taking our pencil over, we notice that there are arrows at the end of this relation. So we cannot assume that it's going to end at a certain point. Those arrows mean that it's going to keep going. This is just a zoomed in version of this graph. Okay, we can guess that it may keep on going until infinity. Okay, so with this domain, it must be greater than or equal to 0, but then it can be any other number that is greater than 0. So for this one, what we're going to write is we have x such that x is greater than or equal to 0, because that is all that we know. That is all that is given to us. We know that it must be greater than or equal to 0. Now we're at number 7. And number 7 gives us a function on the graph and is asking for f of 5. So that means when x equals 5, we're going to write, our answer is going to be whatever the y value is. So we need to look at when x is 5. Here is my x-axis is horizontal, and here is 5. And when I go down, that's where I hit my function. And so I can realize that this would be -2. You just got to be careful because sometimes with the lines, it's like every 2 lines only counts for a total of 1, so just be careful. But this would be -2, so that means that f of 5 equals -2 because my y value is 2. Now we're going to continue to use the graph above. This one is asking what is x when f of x equals 5. So in this case, this 5, and I didn't mean to do that, this 5 is our y value, okay, and it's positive. So we need to look at the y-axis, which goes up and down, and we need to look at +5, and then we need to figure out, do we need to go to the left or do we need to go to the right to hit our function? We need to go to the left. So when we go to the left and we follow +5, when y equals +5, we're going to hit our function right there. And so you need to see what is the x value for that function, and the x value, if we were to go down, is -10. Okay, so maybe this is helpful if I draw those lines for you all. So the answer to this one is x equals -10. Okay, so now we are on page 4. I'm at question number 9, and number 9 gives me a function, and it's asking me to find f of -3. So what I need to do is plug in -3 into this function. Okay. Okay, so when I am squaring a negative number, I'm going to get a positive result. So 3 times 3, 3 times -3 times -3 is going to give me positive 9. And then over here, I have 3 times -3. So that is going to give me -9. So I'm actually going to erase this addition and write -9. Or -9, either way works. And then lastly, I'm going to bring my 1 down. Okay, so I have 9 minus 9, that gives me 0. I have 0 plus 1. So when f is -3, my y value is 1. So that is my answer. This next one, number 10, is a little tricky. Don't think that it's the same exact way, that we're going to treat it the same exact way as number 9. So it gives us a function, and it's asking us to find f of x equals -6. So that -6 is my y value. So what I need to do in order to solve is set my rule, my function, equal to my y value and solve for x. Because that's what we're looking for. We're looking for x. So -6 equals 2x plus 4. Whoops, sorry. Minus 4. 2x minus 4. All right, so I'm going to add 4 on both sides. When I do that, I get -2 equals 2x. If I was to divide by 2, I would realize that x equals -1. Okay, so there is my answer. All right, now we're at number 11. This question is giving us 2 points and asking for the slope. We know that slope is the change in y, and we can write that with a triangle, change in y over the change in x. So what I need to do is I need to do y2 minus y1 over x2 minus x1, since I'm given both of these points. And I don't have any missing values, and solve, and then I'll get my slope. So the first thing that I'm going to do is I'm going to label these points off to the side. I'm actually going to use a different color, so hold on 1 second. I'm going to use green. So I have -2, 2, and then I have 4 and -1. I'm going to label these with red. So here's my x1 and my x2, and then my y1 and my y2. Okay, so now I can go ahead and put them into this formula. So y2 is -1 minus +2, and then my x2 is 4 minus a -2, so that's really going to be adding, so I'm just going to switch this to addition. Okay, now we just need to combine the numerator, combine the denominator, and then reduce. So -1 minus 2 is going to give me -3. And then 4 plus 2 gives me +6. I know that I can reduce this to -1/2. So that's my slope, -1/2. This is a negative slope. So what you would do if you needed to graph this is you would go down 1 over to the right 2. Number 12 is asking us for the slope and y-intercept of the function that is given. The function is f of x equals -1/4 x minus 1. This is in slope-intercept form, so this is super easy for us. Slope-intercept form is y equals mx plus b. M is our slope and B is our y-intercept. So all we need to do for this problem is just be able to recognize what is the slope and what is the y-intercept and write it down. So our slope is -1/4 because that is what is in front of x. And then our b for this function is -1. And then if you were to graph this, you just want to make sure that you use both the y-intercept and the slope to help you graph. Okay, so now we are at question 13, and 13 asks, what value of x will the slope between the following points be undefined? So we know that we have an undefined slope when we have a vertical line, and I remember my acronym VUX, V-U-X. So V stands for vertical line, U stands for undefined slope, and then X stands for x-axis because it's going to go through the x-axis, and also it's going to have the same x value. Okay, so it's not going to pass the vertical line test because the only value it's going to go through is that one x value. So we need to look at our x for these coordinates. So in order for this to create a vertical line, that x would need to be equal to the same x in the other ordered pair. Okay, so that x needs to be equal to 2. If we were talking about a horizontal line, then you would be looking at the y values, because if we use the acronym HOY, H-O-Y, we create a horizontal line when the slope is 0 and it passes through the y-axis. And so if this had a missing y value, then we would want to make sure that like our missing y value matches our other y values. So just in case you see this in the future, that's how you would solve it if it was talking about a 0 slope or a horizontal line. Okay, number 14 is asking us to solve for a missing value. It gives us the equation and it gives us slope. So the first thing that we need to do is we need to put this in slope-intercept form. I don't know if you can hear my cat purring, but she's purring very loudly right next to the microphone. Okay, so slope-intercept form looks like this. Y equals mx plus b. So the first thing that we need to do is work with this equation, move it around a little bit so it matches this format. Okay, so I'm going to rewrite it over here. Okay, so the first thing that we need to do is let's move this 15 over to the right side. I'm going to draw an arrow and I'm going to work over here now. Okay, so I have AY equals, and I'm going to put a 1 in front of my x. It's going to make my life a little easier. You'll see why in a second. So I have 1x minus 15. Now I need to divide by a because I want y by itself. On the right-hand side, I divide each value by a. Okay, I'm going to leave that x off to the side because in the end, I want to keep that x because I'm looking for what my a is. All right, so let's go ahead and clean this up a bit. So on the left side, we'll have y by itself. Then we'll have 1 over a, and then x on the side. And then we're going to have minus 15 over a. I know that's kind of weird, but what we can do now is, since it gives us our slope and m is in front of x, then we can set what is in front of x equal to this. Okay, so we're going to set up a proportion. So we have 1 over, then this is not the answer. I'm just running out of room, so that's why I'm writing over here. Let me move this up, actually. Okay, so we have 1 over a is equal to -1/3. Okay, so we're going to set up a proportion and cross multiply to solve for a. So when I multiply, I get 3. And then when I multiply, I get negative 1a. And it doesn't really matter where you put the negative. You just need to make sure that you put it somewhere. Okay. And so if you did it this way, then you have to divide by negative 1 on both sides. And so you get a equals negative 3. Okay, so I found my answer. If it also asked for you to get the y-intercept, then what you would need to do is just plug that a in for the 15. It will probably not ask you that, but I just want you guys to understand that if like you wanted to graph this, that's how you would do this. All right, so number 15, what is the x-intercept and the y-intercept for the equation 2x minus y? I'm just going to go ahead and put it in slope-intercept form. It makes my life just a little bit easier. So I have 2x minus y equals negative 4. And I need to subtract 2x on both sides. So now I have negative y equals negative 2x minus 4. I need to divide by negative 1 on both sides because I have a negative y, I want a positive y. So when I do that, I get y equals 2x plus 4. Okay, to get your y-intercept, you don't really need to do anything. It's right there for you. So here it is, it's 4. And if you wanted to write this more formally, if it was asking like what is the ordered pair for the y-intercepts, so that's when your x is 0 and your y is 4. And then in order to get the x-intercept, we need to plug in 0 for y and see what we get. So that's what I'm going to do over here in red. So when I plug in 0 for y, I get 2x plus 4. Now I'm going to subtract 4 on both sides, so I get negative 4 equals 2x. I divide by 2 on both sides, so I get x equals negative 2. So that's my x-intercept. And so it's negative 2. And again, if it asks for like what is the ordered pairs, then you know that the x value would be negative 2 and the y value would be 0. Okay, so this question 16 asks, what are the zeros of the following function? You know how to do this, but you may have not have seen this written in this way before. It gives us the function, and basically it's asking what is f of x equals 0, and you're looking for x. So you need to set, let's do this in blue. You need to set the function equal to 0 and solve for x. So let's go ahead and do that. So 0 equals 2x minus 4. Add 4 to both sides. We actually just did this earlier. And we get 4 equals 2x. We didn't do this earlier, but it looks similar to the one that we just did. And then we need to divide by 2, and when we do that, we get x equals 2. So that means that when y is 0, x is going to be 2, and that is my 0 for this function. So I know direct variation is something that you have recently learned. However, it is going to be on the test, so we want to make sure that we cover it in this review and that you feel comfortable with problems dealing with direct and indirect variation. So the equation for direct variation is y equals k times x. However, when we are solving for a missing value, then we're going to use, and I'm going to write this in green, we're going to use y over x equals y over x. So we're going to set them up kind of like a proportion. Okay, so let's go ahead and do that. So we have our x and y values. So I'm going to do 16 over 8 equals, we don't know what this y is, so I'm going to actually write n because that is the variable that it gives you. So n over 5. And then what we're going to do is we're going to cross multiply and solve for n, and then we'll get our value. So when I do 16 times 5, 10 times 5 gives me 50, 6 times 5 gives me 30, 50 plus 30 gives me 80, and then 8 times n gives me 8n. So now I just divide both sides by 8, and so I get n equals 10. So my missing value was 10. Okay, so now we are on the last page. We are at question 18. And question 18 says, in an inverse variation, y equals 2 and x equals 12. Write an inverse variation equation that shows the relationship between x and y. Okay, you need to have the inverse variation equation memorized, and that is y equals k over x. K is the constant of variation. We can solve for k because we have our x values. So we have y, which is 2, and then we have x, which is 12. If I multiply both sides by 12, I can solve for k. So I realize that k is equal to 24. Okay, so now I'm going to write my equation, and it can be written two different ways. So I recommend you writing it in the format in which we originally used, like this. So y equals 24 over x, because we realized that that k is 24. Or you can write it as x times y is equal to 24. Okay, either way works. Okay, so now we are working with number 19. Number 19 asks, two relationships are described below. Relationship A, Alejandro's science project has a total of 3 people. 3 people can finish the project in 4 hours. If they had 6 people in their group, they could finish the job in 2 hours, or the project in 2 hours. Relationship B, Beverly ran 3 miles in 27 minutes, and then she ran 5 miles in 45 minutes. Which statement is true about these relationships? So then we have options that say that there's no variation in either relationship. Both have direct variation. Relationship A has direct variation. Relationship B has inverse variation. Relationship A has inverse variation, and relationship B has direct variation. So let's go ahead and first look at the relationships between these numbers in relationship A. So if I was to set this up as my x values and my y values, I would realize that 3 people, that's my x, finished the project in 4 hours, whereas 6 people would finish the job in 2 hours. So when I go from 3 to 6, I multiply by 2. However, when I go from 4 to 2, as you can tell, I have not multiplied by 2. So because of this, I know that it can't be direct variation. However, I need to check for inverse variation. So now I'm gonna look at the relationship between the x and the y for each set. So right here, if I multiply my x and my y, 3 times 4, I get 12. If I multiply my 6 and my 2, I get 12. So this has an inverse variation. So relationship A is an inverse variation. Okay, now let's look at relationship B with Beverly. So I'm going to write X and Y. Let's let miles be X, so 3 miles, and Y be minutes, 27. And then 5 miles and 45 minutes. So to check for direct variation, as you can tell, going from 3 to 5 does not occur naturally. So we can kind of set this up as a ratio like we would do if we were like solving for a missing value, and just check to make sure that they are equal to one another. So for example, I got to put my y's on top and then my x's in the denominator. So my first y is 27 and my first x is 3, and then I have 45 over 5. Okay, so when I do 27 divided by 3, I get 9. When I do 45 divided by 5, I also get 9. So this is a direct variation. You could also check to see if it's inverse variation, and I'm going to do that in red. So if you wanted to check inverse variation first, when we do that, we have x times y equals x times y. If we do 3 times 27, and then over here we have 5 times 45. When we do 3 times 27, we get 81. When we do 5 times 45, we get 225. These are not equal. Therefore, this is not an inverse variation. This is a direct variation. So I'm going to erase over here, and I'm going to write direct variation. Okay, so our correct answer is D, because it says that A is inverse and B is direct. This last question is asking us the points on the graph below, and should say the point on the graph below, sorry about that, is from direct variations. Plot 2 more points on the graph that will also represent the same direct variation. Sorry about that. So whenever we have a direct variation, it's going to create a line through the origin. So we know that we can always plot the point 0, 0. And the ratio for the ordered pairs in a direct variation is y over x. So our y value for this one is going to be 8, and then our x value is 4. So this is our slope. This is going to simplify to 2, so our slope is 2. So guys, we can plot more points because what we're doing, slope is rise over run. So we're doing up 2 over 1. So we can plot a ton of points. Hopefully this is helpful for you if you get this question in the future and you need help with adding points to the graph. All right, I hope this video was helpful. Please reach out to your teacher if you have any questions or are confused about any of these questions. I hope you have a wonderful rest of your day. Thanks for watching.